All right, today we're talking about probability again, and there's a quiz tomorrow, so we're reviewing for that quiz. I'm going to recommend that we jump right to this next slide. Basically, we're reviewing probability and frequency, and then doing all kinds of expected value problems. All right, the Venn diagrams are the first part of the quiz, and they're a part that I hope will be easy for you, but it really depends on the kid. If we take a look at this one, the key things were it, and or. Do you remember which ones are a bigger answer, and or or? Or are the big answers, and they include not everything, but they include lots of things. If you are a rock climber or a snowboarder, it's this, this, and this. And why? Because if you ask these people, do you rock climb or snowboard, and you force them to say yes or no, they would say yes, because they do one or the other. Do you rock climb or snowboard? They'd say yes. Again, they might clarify and do both, but they'd say yes. And these guys would say yes. So it's or is all of them, and is which one? That one. Okay. And what if I want to do a given? Given that the person was a rock climber or whatever. What does a given do? Say it was just a rock climber. What's special about this then? It's not out of 100 anymore. Good. If it's given it's a rock climber, it's now out of those two. So it should be 59 on the bottom. You take those two, put them on the bottom. And then, here's the most important part, and I really can't stress this enough. Your mistake kids are going to make is they are going to be picking one of these numbers. And they can't. Why? Because these aren't allowed. We said given it's a rock climber. So therefore, the other ones can't work. Okay, then when they say something like, what's the probability they're only a rock climber, then you'd choose this one. Or if they said, what's the probability that they also snowboard, then again, you'd be tempted to pick that one because they snowboard, but they're not possible. These are the only possible snowboarders, so you'd have to go like that. Do you get those generally? All right, try to answer these three questions that you see on your iPad. I would like you to divide them and get the decimal. So grab a calculator if you haven't already. Now pause for a second while you try to answer those. There's actually 4 of them. Okay, so here are the first 2 answers. What's the probability a randomly chosen rock climber is a snowboarder? As soon as they said they are a rock climber, I was zeroing in on these 2, and I can't use those. Is a snowboarder. So we got 0.47. Out of, together they make 0.59. I hope this is right. Is that right? 797? All right, good. On to the next one. Rock climber or snowboarder. All right, or means the big answer. So we put all of those together. All of these added up and technically divided by 1, because everything was possible. Just a randomly chosen person. All right, so that one's 0.94. And this next one is, what's the probability a randomly chosen person is a rock climber and a snowboarder? And means the smaller answer. That's just the one in the middle, 0.47. Technically, you divide it by 1, so and either way it's 0.47. And now this last one, which I don't think is on your screen. Would you try this last one? It's on the smartboard only. Given a randomly selected person is not a rock climber. That's a given. What's the probability he or she is not a snowboarder? Yes. Okay. Okay, the question does say or. Do you agree? Okay. And it doesn't say given, right? It's a randomly chosen person. So as soon as they say or, and it's not a given question, then all you have to do is add these up. That's it. Okay? Now you may have a follow-up question after that. Please ask. But that's how you do that problem. If you want to change the problem, then we got to obviously do it differently. But All right, that last one. Given that they are not a rock climber, what I would do on my test, I would be using a pencil so I can constantly change what I'm crossing off, but they're not a rock climber. They can't be this and they can't be that, right? That leaves me the other two are my only possibles. So I would add them up together and put them on the bottom right away. I'd say by far more mistakes are on the bottom than on the top. So they add up to 0.41. Then, probability that he or she is not a snowboarder. Okay, so which is the one I want? I want that one, because they are the people that are not snowboarders. So 0.06 over 0.41. Did it come up to 146? All right, good. Okay, any questions on that? Remember, if they say given, or if they say something that means given, like randomly chosen rock climber, that means they're giving you that it's a rock climber. All right. Givens mean you have to have a denominator. All right, we've got iPad, cat, and phone. This is one where you have to actually make a Venn. And this is one of the hardest kind of questions that is on the test. We get a lot of kids get it wrong. What was my advice to you on making a triple Venn? Start in the middle and then go outwards from there. Okay, so go ahead. Find, if they did tell us the middle, put it in right away. Go ahead, take some time, work through this one. You need to practice to get good at this. Looks like they did not give us the middle one on this one, so this is one of the harder kinds. It's not even that hard, but since they didn't give us the middle, they had to give us a bunch of other numbers. Do you get when they say 51 people were surveyed, you put a 51 up here? That's where the total is. You don't even have to put that there. It's just like a smart thing to do. 26 people have an iPod. I would not put the 26 here because the total's got to be 26, so I would put the 26 right there. 4 people don't have an iPod, cat, or phone. That's down here. There's no little blank for it, but 4 people don't have any of it, so they're they're the extra people, the neithers. 12 people have a phone, but not a cat or iPod. Ooh, that's a big one. That tells us an exact number. The iPod one. 4 have an iPod and a cat. That would be in this zone, but not a phone. So that means it can't be here. So that number they just gave us, right there, the 4. No, wait, I'm wrong. What number is it there? There we go. Trying again. I'm working on this 12 here. I should actually probably cross off the ones I've used. I've used that, and that. Okay. 12 people have a phone, but not a cat or iPod. Okay, phone, but not a cat, not an iPod. So it can't be here, can't be here, can't be here. So it has to be just the phone spot, so it would be a 4 right there. You agree with that? Or is it 12? Try 12. I was sick yesterday. I don't think my brain's quite back to top speed yet. All right. We got that number done. Anyway, keep going from there. Once you're done with that, if you are a fast worker, if you want to work on the next slide, that'd be totally fine. I'll be back in just a second. So I'm back from the little break there, and let's see how these numbers should have turned out. They look like that. 8, 4, and 3 going across the top, 5, 9, and 6, a 12, and then a 4. Now, if you screwed one of those up, there's your point. Boink, it's gone. Do you have any questions about how did this number happen? Okay, then let's move on. What's the probability that a randomly chosen person has a cat or a phone? All right, using this chart that we made now, have you already done this question? Raise your hand if you've already done that question. All right, then we should do it right now. Try the randomly chosen person has a cat or phone. Try all 3 questions. I'll pause for a second while you do that. Okay, so here we go. Cat or phone. Is that a big answer? Yeah. Yes. So you find the cat, phone, and is it pretty much all of these? All right. So they take that and you divide by a total, which was 51. Did you get 0.765? All right. I'll warn you, there's one of these numbers is wrong. I was told ahead of time that one of these numbers is wrong. So don't just trust that my number's for sure right. How many of you had 0.765? All right. That's the vast majority of the class, so that's probably right. Okay. The next one. What is the probability a randomly chosen person has an iPod and a cat? And is a small answer. So let me get that off of there. iPad and, or pod and cat would be these two together, I believe. So we're talking 13 out of 51. 275, is that correct? Raise your hand if you had that one. Only three people? Is that because you, okay, who had an answer different than that? Okay, at least so. Ah, that might be the one. Okay, so 9 and 4 makes 13. 13 out of 51. Are we agreed that that's what it is? Okay, and then I just got to grab a calculator here. 13 divided by 51. 255. Yeah, 255 instead of 275. All right. Thank you for helping me find that mistake. And the last one is, given the person has a phone. All right, so right away I'd do this. Given they have a phone, only these are possible. Not possible. Not possible. Now I got a whole new problem. And it's not out of 51 anymore. It's out of all of this, which is 9 and 12. I'm going to add these together first. Makes 21 plus 11 makes 32. So 32 possible. Okay, so I'm going to make this out of 32. And then probability also have an iPod. Okay, iPod was these. These both have iPods, right? So 5 and 9 is 14, so I believe the answer would be 14 out of 32. And 0.438, that's a little less than half. That makes sense. Raise your hand if you had that one right. Okay, good. Given that the randomly selected, okay, I think we've done enough of these. Good enough. Unless if you did that, I should be fair to you and say, all right, here's the answer. 0.414, if you did it, that's what you should have had. Okay, moving on. Let's do the expected value kind. I'd say that they are a little harder because they're like word problems and you gotta try to figure out what the tree looks like. I would always do P times A, then add. I might even write that at the top of my quiz for all the expected value, not that you have to write it each time, but just don't forget that it always comes down to this. All right. But digital picture frame, $100, protection plan, 3 in every 200 break. Okay, so what's the probability thing? Make a little tree. What are the things that could happen? It works or it breaks. Works, breaks. All right, see if you can do this one. This is a review day. You should know how to do it. If you don't, I'll show you in a minute, but give it at least get started. Figure out your probabilities, put them there and there. Figure out your amounts, put them here, and you're going to multiply them. Pause for a second while you work on that one. Okay, let's see if you're started right. The probability, 3 out of 200 break. 3 out of 200. That means 197 out of 200 work. Then those are going to get multiplied by how much you get. You go back to the store with your working frame, and what are they going to give you? Nothing. You go back with your broken frame. If it's broken, they're going to give you money back. And specifically, it usually says it covers the cost of the picture frame. There you go. So that's $100. They're going to give your money back. It could get much more complicated if they were only going to repair it, but we always just make it simple and say they give you $100 back. Then, if I multiply that times that, I don't even need to figure out what this is on the calculator because I'm timesing it by 0. Going to get 0. That one I need to do, but I can even do this as a fraction. 3 out of 200 times 100 over 1, and all of a sudden, oh, canceling. I can go cut off a couple zeros off of both of those. Basically, 100 and 200, 100 goes in there once and 100 goes in there twice. Final answer is 3 over 2, and this is in dollars. What's 3 over 2? Same as 1.5, $1.5 now. That means it's worth $1.50 plus this zero, but then realistically adding zero doesn't do anything. $1.50. If so many kids are going to put that as the answer and it'll be multiple choice and then they'll see the answer there and they'll go, oh, there it is, and then they think they're right. Why is that not right? I have to subtract the costs of the protection plan. Okay? I'm telling you, just because the answer's in the multiple choice doesn't mean it's right. We put those there on purpose because they're common mistakes. We want to know if kids know. You're supposed to now subtract the $19.99. Otherwise, all you were figuring out, that's what the value of the warranty is, but you haven't paid for it yet. We didn't use the $19.99 yet. Final answer. Tell me what you got when you subtracted that. 1814? 49, thank you. 1849, and is that positive or negative? Negative, so you are going to lose money on average if you buy this thing. And it makes sense. You're getting something that's worth $1.50 and you paid $20 for it. Of course you're going to lose money on average. Yes? Exactly. So if you're going to lose $18.49, who's going to get that money? The store. Okay, so depends on what the problem says. Let's see what the problem says. What is the store's expected value? Okay, your expected value is what we always figure out to start with. And did you notice that in the directions here? It says, what's the store's expected value? So you got to be careful. The store is going to make money. You are going to lose money. Good catch, Mr. B. All right. Here's another one. And this one's kind of a pain because it has a big chart that you have to do. And I want to save us time of not having to do all of the chart. But I think it's a good problem to do. So I'm just going to show you the chart really quick. And then once we have the chart, we can get the answers a lot quicker. All right, so what are the things that can happen? He's on time or late, right? What's probability he's on time? 0.495. And that means probability he's late, 0.505. Have I got those right? Okay. Then the pain in the neck part is this is a three-step tree. On time, late, on time, late, and then another one. On time, late, on time, late. And this is going to have a whole bunch more branches down here. On time, late, on time, late. Okay. Now that I got the rough outline of the tree, what's the probability he'd be on time 2 days out of 3? Which ones do I want? 2 on times and 1 late. That branch right there has 2 on times and 1 late. This branch here has 2 on times and 1 late. This branch has 2 on times and 1 late. And I think that's it. So I'd need to figure out those 3 probabilities and add them up. What's probability late 1 day out of 3? Late 1 day out of 3, isn't that the exact same thing as on time 2 days out of 3? I think they're just trying to check your reading skills there. And then what's the expected number of days Billy will be on time? Okay, for that one. Expected, ooh, that sounds like expected value. And what formula am I always supposed to use? A times A and then add them up. Okay, what I've got at the end of this tree, all of these probabilities, when you do expected value, you've got to do all of them. Now, I'm not going to do it right now. But all of those would have to be figured out. Got a decimal for all of them. But then the part where people get stumped is, what are they supposed to times it by? They get how to do probability now, but how do what's the amount? Well, they're asking about on time. So what's the amount for this branch of the tree? Well, 3, because he was on time 3 times. So once I figure out that probability is like, 0.144 or whatever it is, then I got to multiply it by what its amount is, and its amount of on-timeness is 3. This one's amount of on-timeness is 2 of them and not that one, so 2. This one's worth only 1 on time. No, wait, that's got 2 on times. This one's got 1 on time and 2 lates, So how many on times? 1. So you're multiplying it by how many on times there were. Okay, that's probably the hardest kind. So that's all I've got for you. You do have problems like money ones. I guess I could just remind you of that. Let's say that there's one $10 bill in my wallet. There's 12 $20 bills in my wallet. And there's, let's say, 5 $5 bills in my wallet. Okay, if you get a random bill from my wallet, how much is it worth on average? It's also known as expected value. Go ahead, try that one. That adds up to 18 total bills. Figure out the expected value for this. I would personally, I'd probably start with a tree. I could get a 10, a 20, or a 5. Help me, what was 1/18 as a decimal? Somebody must have divided that by now. 0.05 repeating. I'm going to go with 0.56 then. And then 12 $20 bills. 12 out of 18 were 20s. So 12/18, what decimal is that? Thank you. And last but not least, the 5s. 5 out of 18 of the bills were 5s. What was 5/18? 2 what? Thank you, 0.278 then. All right. Got my probabilities. Now I got to times by the amounts. Well, that's easy. In this case, it's money. So it's $10 for that one. It's $20 for that one. And it's $5 for that one. Once you multiply that and that and that together, you get 3 answers, and then you add them all up. Who's got it? Raise your hand if you've already got the total. All right, then I'm going to wait for a minute until you figure it out. It's just simple multiplication. Got an answer or question? Cool. Just hold on a minute. I want to let everybody get it. And if you say it right, they'll all quit. Once you do finish, go ahead and go into Schoology and find the homework, which is called 12.3, 12.4 review. And the review assignments, to me, are always the most important homework that you do. Because the quiz is the next day, and if you don't check those, you're really missing out on a chance to improve your grade. Because number one, the homework goes into the grade book, and sometimes people think that the one right before the test doesn't go in the grade book. It does just as much as any other homework assignment does. In other words, I'm not promising it for sure will go in, but sometimes they do, sometimes they don't. But it's also the most important one to check, because if you screw up a bunch of things, you realize, oh my gosh, I know I'm not doing this right. You're catching yourself at just the right moment to fix it, right before the test. So check your homework tonight. If you never check, check. And you can always come in the morning to get help, unless it's a Wednesday, but tomorrow is a Friday, so yes, you can come in the morning. All right, now how many people have an answer? I'm up to like 3/4 of the class. I'm going to say I'm going to go for it. What'd you get? Nope. Oh, go ahead. I was going to take somebody else, but go ahead. Give me yours. I'll get different opinions. Go ahead. Sorry. Go ahead. Now, just think about it for a second. Does that seem like a reasonable amount to pay to play that game? It's going to be less than 20, right? Definitely worth more than 5, right? So something between 15 or between 5 and 20. And there's a lot of 20s in there. That makes it probably worth at least 10. And then, yeah, I think 15 seems reasonable. Raise your hand if you had the same thing as he did. Okay, awesome. So that's the kind of stuff you have to know for your test for tomorrow. And there is homework tonight. It is posted on Schoology. The answers are posted on Schoology. Beware, teachers sometimes screw up. Sometimes there's an answer wrong on the homework. Don't let that make you think you're totally awful at this. It might just be a wrong answer on the key. As soon as you find out there's a wrong answer, let us know, and then we'll post underneath it in the little comments on Schoology. We'll post, oh, looks like answer to number 5 is wrong or whatever, so that you can look in the comments and see if there's a mistake. All right, that's all I got for you for today on the video.